Hello everyone. The first classification of finite automata without output is deterministic finite automata. In short form, it is called as DFA. In brief words, DFA is a simple machine which can goes to a single state whenever you give some inputs to them. Okay. So let's take the definitions first. So it is a collection of 5 tuples. Okay, tuple is, you can study tuple in Python language also. So tuple is the collection of symbols. So it is a collection of 5 tuples, and the 5 tuples are Q, capital Q, sigma, delta, Q naught, F. Okay. Deterministic finite automata is a collection of 5 tuples Q, sigma, delta, Q naught and F. What are these symbols? This capital Q represent finite set of states. So capital Q is finite set of states. What is state? In a theory of computation, you can represent any state with circle. Okay, so there are basically 3 types of state. First one is the initial state. Initial state is identified with arrow along with the circle. So this is called as initial state. Second one is final state. Final state is nothing but double shaped circle. So in a circle, inside a circle is formed, and normal circle is called as an intermediate state. Okay, so this 3 shape you can identify with states. One is initial state, the next one is final state, and the last one is intermediate state. Second symbol sigma is input alphabet. So if you remember, in the first video discussing the 4 pillars of theory of computation, I have mentioned the word alphabet. Alphabet is the collection of symbols. Symbols is small a, small b, letters, digit or alphabet. So input alphabet can either be small a, small b, small c and so on. Third one is delta. Delta is the transition function. Okay, and the transition function in deterministic finite automata is Q cross sigma tends to capital Q. I will tell you shortly what this particular formula represent with the help of example. First of all, we need to understand what are the symbols represent. So we can cover Q, sigma, delta and then Q naught. Q naught is initial state. Initial state means where you start a simple machine. So if you have some input and if you have a simple machine, then with the help of this particular input, how can you start the machine? So from some state you can start with the machine. This state is nothing but the initial state, and initial state is identified by the arrow along with circle. Okay, and the last tuple is final state, and final state may be one or more. So I can here write is final states, and final state is always a proper subset of the finite set of state. So capital F is always a proper subset of capital Q. Okay, so these are the basic concepts which you know in deterministic finite automata. So let's take an example. The example will be much more meaningful to you rather than discussing this formal definitions. So let's take a language L1, set of all strings which starts with small a, and the alphabet it contains either A or B. So these two alphabets are used in this language L1, and the language is set of all strings which starts with A. So here A is what? Here A is input alphabet. So can you identify the language L1 is either finite or infinite? Can you answer? Definitely L1 is infinite language because there are infinite strings formed with the help of symbol small a. So the language will look like this: A, AB, ABA, ABB, AB, and so on. So easily you can identify that each string in the language L1 is start with A. Okay. So how can I form a simple machine for this language L1? And this simple machine will be in the part of deterministic finite automata. So in this particular deterministic finite automata for language L1, I will form a simple machine which can go to some particular state by seeing some input symbol. So with the help of a state, the state shape is in circle form. So I can form the machine. I will start with the initial state. Let's call it initial state as capital A. And after saying a small a alphabet, I will go to the state capital B, which is final state. And in the final state, I will accept any number of A's or any number of B's. No problem, because the condition here is input or string starts with A. And what will happen if I start with B? If I start with B, then I will go to some other state. Let's call this state as C. And this state in deterministic finite automata called as dead state, or you can say trap state. Okay, and dead state, you can accept either any number of A's or any number of B's, which will not matter. So definitely, if I see a symbol A on state A, then I will go to the final state capital B. If I see a symbol B, then I will go to the dead state capital C. So this is the finite representation of this machine. Okay, this is finite representation of this particular language L1. Now if I give some input string, let's say W is equal to AAB. So can you trace whether this string AAB belongs to the particular language L1 or not? Easily you can trace this. You can start with A. So AAB. So first of all, you can start with capital A state. On seeing small a, you will go to the state B. And on state B, you can accept any number of A's or any number of B's. At the end, if you reach final state, then that means the string is belong to the language L1. Let's take some other string. Let's say the string is BBA. If I start with initial state A, capital A, if I see a symbol B, then I will go to the state capital C. On capital C, I can accept any number of A's or any number of B's. But at the end, I will stuck at the state which is not final state. So C is not a final state. So definitely I can say that this particular string does not belong to the language L1. Understood that? So what are the possible questions which will ask in this deterministic finite automata? First of all, you given some language and given some finite representation and ask whether the string belongs to the language L1 or not. Okay, so let's take some more example. In the next video we will see some more examples related to deterministic finite automata.